Relax, Diegos. All right. Okay, so eyeballs up here, phones away, earphones off. Thank you so much. So, on your paper, Ekasan, on your paper, the title from 2 days ago is Simple Graphs of Quadratics. Step 1. If you were absent, you'll copy down step 1 later. Put equation in standard form. Step 2. Determine whether the parabola opens up or down. If A is positive, it opens up. If A is negative, it opens down. Step 3, find the vertex. We just did this for warm-up. Again, if you're absent, you can copy this down later. We're going to go into step 4 and 5 now. Let's do it. So, on your notes, let's go on to step 5. Yeah, 4 rather. I'm going to coffee. I need more coffee. Step 4. Here we go. You may. Step 4. Ready? Find the roots or x-intercepts, they mean the same thing, of the equation. Use a quadratic formula. Find the roots or x-intercepts of the equation. Use a quadratic formula. We're going to continue with the exact same equation from 2 days ago, which was, we're going to do step 4 and 5 right now. So step 4, let's find the roots or x-intercepts of the equation. What equation? Well, the one we did for our first example on Monday was y equals, let's do it from example 1. I'm going to borrow the example 1's equation right here, this one. Y equals x squared plus 2x plus 5. So let me rewrite the equation. Y equals 2x squared, or is it x squared? X squared plus 2x plus 5. So this is from example 1, this equation. This is not a new equation. This is from 2 days ago. We did this in example 1. We found the vertex. The vertex was, for example 1, the vertex was, let's see, negative 1, 4. Right? This is example 1. It's on your notes. So now what we're going to do is to do step 4. We're going to find the roots. The roots or the x-intercepts mean the same thing. Williams, I got the floor, buddy. You're the man. Earphones off too. Third time I said it. So they mean the same thing. Roots and x-intercepts are, in English, they call them synonyms, not synonyms. Two words that mean the same thing. So roots or x-intercepts mean the same thing. Let's find them. How are we going to find them? We're going to apply the quadratic formula. What is a quadratic formula? Well, we did that last week. You guys should have memorized that by now. The quadratic formula looks like that. Remember this? Remember all the fun you had with this? Stop lying. Stop lying. Tell him, Gallegos. So, recall that when we use a quadratic formula, negative b plus or minus b squared minus 4ac all over 2a, the first thing we've got to do is make y what?
0.
You're the man. Make y 0 plus 2x plus 5. By the way, that's gonna be on YouTube. You're gonna hear yourself. 0.
Hey, Mom.
That was Mr. Gallegos. All right, thank you. All right, so Murillo's absolutely right. We make y 0, and now we're going to plug and chug. We have to substitute A, we have to substitute B, we have to substitute C into our quadratic formula, and we're ready to rock and roll. Who likes rock and roll? So now, here we go. Our A, B, and C. A is 1, B is 2, C is 5. Let's rock and roll, Sevilla. Let's do it. Negative B really means negative 1 times B. B in this case is 2. Plus and minus. Remember we did this for like maybe a week and a half last week. So this is, you're no stranger to this. Square root. B squared is 2 squared minus 4 times A. That's 1 times C is 5. We're rocking and rolling. All over 2 times A. That's 2 times 1. Nice. Sure. So again, this is step 3. Oh, step 4, what am I saying? Coffee time. I'm just going to flip it over. So if you don't have any room, you're going to flip the page over. If you don't have more room, I got more graph paper. No problem, no problem. Anybody need some more? We're good? Later. Here we go. You're so adorable. You're so adorable. All right, watch this. All this part that I'm highlighting in Dodger blue, remember that's the part that gives us the most trouble. Let's simplify that first. Thank you, gentlemen. Here we go. Let's do it. So I'm coming off to the side and just dealing with the square root. Remember that? The good old days? Let's do it. 2 squared is going to be 4 minus 4 times 1 times 5. Let's keep going. 4, negative 4 times 1 is a negative 4 times a 5. So 4 minus 20, so it'll be a negative 16. So far, so good. All right, watch this now. So the square root of negative 16 is what we call an imaginary number. It's an imaginary number. It's not a real number. In other words, there's no such number times itself that becomes negative 16. Matter of fact, is that negative 16?
And negative 4 times negative 4 equals positive.
Right. So what I need from you, if you can prove me wrong, what is a number times itself that becomes negative 16? If you can find that, you're going to be on CNN tonight, Larry King Live. You'll be on the Guinness Book of World Record. So right now, hold up. Right now, what you need to write on your notes while you're thinking about it, if you think you can get the CNN interview by tonight, while you're thinking of that, go on your notes, go and write no roots. Because square root of negative 16 is not a real number. It's not real. It's imaginary. We're going to get into imaginary numbers next week. Thanks, Williams, for that scholarly assessment and intelligent commentary. It's going to be all right. It's going to be all right. So, whenever you come up with a square root of a negative number, that means the parabola has no roots. Or, remember the synonym for roots is x-intercepts. We're dealing with, remember the discriminant? When it tells us how many x-intercepts a parabola has, if it doesn't cross the x-axis, you have a discriminant of a negative number. Look at the discriminant became a negative number. So the graph of this parabola is never going to cross the x-axis. It doesn't have any x-intercepts. So now, step 5. Last step on your notes. Here we go. Step 5. Plot the vertex and the x-intercepts on your coordinate plane and sketch the parabola, the parabola. Plot the vertex and the x-intercepts on your coordinate plane and sketch the parabola. Let's do it. So let me get my graph paper for myself here. So you guys going to make an X and Y axis on your graph paper? You don't have to put all the numbers there. Just make sure your lines are straight along the graph paper lines. That's the whole point of graph paper. Don't just give me some bootleg crappy line. Put it on the graph paper line so it's nice and neat, and you have your intervals of your graph paper. Anybody? Example 1 from Monday, that's the equation we're dealing with. This equation from example 1, can someone please tell me the vertex that we found? Negative 1, 4. Do that with me. Watch this. Negative 1, positive 4. 55. So plot negative 1, positive 4 with me. We're on step 5 now. We plotted the vertex. Plot rhymes with dot. So when I say plot something, that means make a dot on something. Plot the vertex. So far, so good. And we got to plot the x-intercepts. But was there any x-intercepts? Let's see. Remember, we had a negative number. The parabola does not cross the x-axis. Okay? So it doesn't cross it at all. So it's going to be a parabola. It's going to be a parabola that opens up because A is positive. Remember from step 1, way back on Monday? Watch this. If you look at your notes, if A, actually step 2, if A is positive, the parabola opens up. If A is negative, it opens down. So looking at this equation here, it opens, let's see, does it? What is A? Is A positive or negative? So A is 1, so that's positive, so it's going to open up. So here's your parabola. Check it out. It opens up. Put arrows. It goes on infinitely. We just graphed the simple parabola. It didn't cross the x-axis. So it opens up because A is positive, and there's your vertex. We're rocking and rolling. Who likes rock and roll? Yeah, he was.
Can I use that to recall me?
Sure, why not?